Hello, we are discussing about GATE 2004 ECE paper. For the lattice circuit shown, given ZA value J2, ZB is 2 ohms. Find the value of impedance parameters, that is Z parameters of the circuit shown. So this lattice network is now assumed as 2-port network, and for a 2-port network, Z parameters are defined in this way. Okay. So Z11, Z12, Z21, Z22 can be calculated by using these equations. Z11 and Z21 can be calculated by making I2 is equal to 0. Z12, Z22 can be calculated by making I1 is equal to 0. Where I1, V1 are related to port 1, I2, V2 are related to port 2. So this is port 1. Left side is assumed as port 1. So V1 and current coming from this one is I1. V2 and current entering into this side is I2. Okay. V1 is a voltage, that's what applied. Across 1 and 2 terminals, and this is plus minus, and it will be assumed as reference node. And V2 is the voltage applied across 3 and 4, and current is I2 when V2 is applied. But V2 we are not applying externally. Since I2 is equal to, we are making 0 to calculate Z11, Z21. We only apply V1. Okay. By that time you may get a voltage V2. It doesn't matter. You will get V2 because V1 is applied. But we are not explicitly applying V2. Remember that one. Since you are not explicitly applying V2, that is externally you are not applying V2 voltage. So there will be no port 2 current. I2 is equal to 0. But you may get a voltage whenever you are applying V1. So now we are going to calculate Z11. Z11 can be calculated by taking KCL across this point. Voltage across this point is V1. KCL is you can apply across this node by that time. Okay, currents are flowing in this direction. Since I2 is equal to 0, the same current is also entering into this one. Because the same current plus 0, you will get the same current which is also flowing through this ZB. So this current is going through ZB and next ZA, and it is coming back to this ground. Okay, and next current is this one. It is going through ZA, and I2 is equal to 0, so it won't go that side. It is coming into this side, same current, and it is coming back to ground. So now applying KCL at V1 will give, okay, incoming currents is equal to outgoing currents. Incoming current is I1, which is equal to outgoing currents are these two. Okay, so red color is indicating V1 divided by impedance going through this current. ZA and ZB are the impedances. So V1 divided by ZA plus ZB, and next for this current, this is also ZB and ZA. So again you are writing the same one, V1 divided by ZA plus ZB. That you can write it as 2 times of V1 divided by ZA plus ZB. All these things you are getting since I2 is equal to 0. So you can define Z11 is equal to V1 divided by I1 with I2 is equal to 0. This equation you got because of I2 is equal to 0. So this is equal to ZA plus ZB divided by 2. ZA is 2J plus 2 divided by 2, which is nothing but J plus 1. J plus 1, or it is also called as 1 plus J. So 1 plus J is Z11 value. Now we are going to calculate Z21. For Z21 also we require I20. So we require voltage V2 and divided by I1. So you must express V2 in terms of I1 with I2 is equal to 0. That gives the value of Z21. Now, can you write what is the value of V2? V2 is nothing but voltage between node 3 and node 4. So you can write as V2 is equal to voltage at node 3 minus voltage at node 4. V2 is port 2 voltage. Port 2 voltage is node 3 minus node 4 voltage. V3 is voltage from this point to reference. V3 is voltage from this point to reference. So what can be the current flowing through this one? Since current flowing through, that is this current is also flowing through ZA and ZB, this current is also flowing through ZA ZB. According to current division rule, whenever you are going with equal resistances or equal impedances, okay, the current is going to be gets divided into half. If you are going with same value of resistances, current will be I by 2 and I by 2 according to current division rule. So that since impedances in both the branches are going to be same, so that current flowing through this one is I1 by 2, current flowing through this one is I1 by 2. So same I1 by 2 is also flowing through this one, same I1 by 2 is also flowing through this one. Now Z3 is from node 3 to reference ground. So V2 is equal to node 3 to reference. Reference is this point. So voltage drop across ZA. ZA into I1 by 2. You can write it as I1 by 2 into ZA minus V4 is the voltage from this point to reference ground. Reference is, okay, this point, and from this one current flowing through this one is I1 by 2 into ZB. So you can write it as V2 is equal to I1 common ZA minus ZB divided by 2. So you can write it as V2 by I1 with I2 is equal to 0 is Z21. Z21 can be written as ZA minus ZB by 2. ZA minus ZB by 2. ZA is 2J minus 2 by 2, which is nothing but J minus 1, or it is written as minus 1 plus J. Minus 1 plus J. So minus 1 plus J is Z21, Z11 is 1 plus J. So since if you are looking, the circuit is going to be reciprocal, exactly same whenever you are looking into port 1 or port 2. Circuit is identical if you are looking into port 1 or if you are looking into port 2. So if you close port 2 with I2 is equal to 0, whatever the parameters you will get, same similar parameters you will get when port 1 is 0. So Z11 is same as Z22 and Z21 is same as Z12. Simply ports are interchanged. 1 is replacing with 2. Then Z11 is same as Z22, Z21 is same as Z12. So the right answer for this question is D. D is the right answer for this question.